to really get a handle on this threat, we first have to understand the world we've already built and the security we, let's be honest, kind of take for granted. So let's take a look inside the walls of our digital fortress.
You know, this fortress isn't made of stone and mortar, right? It's built from code and data, and it's all running on the classical computers that power our entire world. It's the digital skeleton that holds our whole society together.
Think about it. Your bank account, the pictures you have saved in the cloud, every single system you log into with a password, those are all treasures locked safely inside these fortress walls. We trust it completely every single day without even thinking about it.
So what's the secret sauce? What is it that actually makes these walls so ridiculously strong? What's the lock on the gate?
Well, it all comes down to a mathematical wall, a giant barrier made of pure encryption, so complex that even the most powerful supercomputers on Earth would need literally thousands of years to break through it. That's the power of modern encryption.
That's a pretty comforting thought, isn't it? A totally unbreakable wall. But what if a new technology showed up that just didn't play by the old rules? What if it could just ignore the wall completely?
And that is the quantum challenger. And we're not just talking about a faster computer here. Oh no. This is a completely different way of computing that changes everything we thought we knew about security.
Okay, so the bricks that make up our digital fortress, they're called bits. They're simple, they're reliable. At any given moment, a bit can be one of two things: a 0 or a 1, off or on. That is it, no in between.
All right, now meet the engine of the quantum challenger, the qubit. And this is where reality starts to get a little weird. Because of a wild principle in quantum mechanics called superposition, a qubit can be a 0, a 1, or it can be both at the exact same time.
So what does that actually mean in the real world? Well, a classical computer, using its bits, has to check one possibility at a time. It goes down the list, step by step. But a quantum computer, with its qubits, can explore every single possible path, all at once. It's massive parallel computation on a scale that's just hard to even imagine.
It's a perfect way to think about it. It's not about building a bigger, stronger battering ram to try and knock down the wall. Quantum computing is like inventing a flying machine from scratch, specifically designed to just soar right over those mathematical walls that have kept us safe for so long.
So, what happens when this flying machine actually gets to our fortress? Well, the implications are staggering.
Right now, today, the encryption protecting your bank is so strong that a classical supercomputer would take thousands of years to crack it. That's the entire foundation of our trust in the digital world. A powerful quantum computer could do the same thing in minutes. Minutes. Just let that sink in. A problem that is for all practical purposes impossible for today's technology becomes trivial. The unbreakable wall just crumbles.
And listen, this isn't some obscure problem. We're talking about the potential collapse of security for our entire financial system, our military communications, the blockchain that powers cryptocurrencies, and yep, all that encrypted data you have stored away thinking it was safe forever.
But the story doesn't end in disaster. Because the world's brightest minds know this challenger is coming, they are in a dead sprint against time. It's a race to forge a whole new kind of shield, one that can actually stand up to a quantum attack.
Right now, there are two main strategies. The first one is to just build new, better mathematical walls. It's called post-quantum cryptography, and the idea is to create encryption that's so complex that even a quantum computer can't figure it out. The second idea is basically to fight fire with fire. It uses the strange laws of quantum physics itself to create perfectly secure communication, and it's called quantum key distribution.
You can really just think of it as a direct security upgrade. Our current encryption standards like RSA and AES that protect so much of the internet today, they're getting replaced by these new post-quantum standards. And where we used to exchange secret keys with old-school methods, we're developing things like quantum key distribution. It's a complete overhaul to defend against a completely new type of attacker.
So, what does this all mean? It means the game is changing. The old rules of digital security are being completely rewritten, right as we speak.
The core idea that has kept our digital world safe, this notion of a mathematical problem that's just too hard for any computer to solve in our lifetime, that idea is becoming obsolete. And this isn't just a patch or some small update, it's a fundamental, deep shift in how we have to protect our information.
The quantum siege is coming. The flying machines are being built, and that leaves us all with one massive question. It's no longer a matter of if our fortress walls will be bypassed, but when. The real question is,
Will our new shields be ready in time?